All right, gonna do some problems, some precalculus problems. If I can find a pen. Hold on. Hold on. Got it. I'm coming. Found my pen. I'm gonna do some problems, precalculus type, section 3.2, logarithmic functions and their graphs. We're going to start with 17 through 20. And here we are taking a logarithmic equation, and we're going to rewrite it as an exponential in its exponential form. So in other words, we're just recognizing, we're practicing kind of knowing what logarithms really are saying to us. So log base 4 of 64 equals 3. That's true because 4 to the third equals 64, because the base to this equals this. Very easy if you know how. This is supposed to be that was number 7, not 17. Sorry about that. Number 9. Log base 7 of 1 over 49 equals negative 2 because 7 to the negative 2 is equal to 1 over 49. Negative exponents flip things over. True fact. Number 11, the log base 32 of 4 is equal to 2/5 because 32 to the 2/5 equals 4. This is a root. 5th root of 32 is 2. Squared is 4. True fact. Log base 2 of the square root of 2 is 1/2 because 2 to the 1/2 is equal to the square root of 2. This is a root. The denominator of your power is a root, and then just to the first power, so square root of 2. That's what it means. 15, going the other direction. 5 to the third is equal to 125. That's true. Can we write it as a logarithm? Log base 5 of 125 equals 3. The logarithm is the exponent. Number 17, 81 to the 1/4 is equal to 3. That's the same as saying the log base 81 of 3 is 1/4. Log base 81 of 3 is the exponent. Number 19, 6 to the negative 2 is equal to 1 over 36. Also true then that log base 6 of 1 over 36 is negative 2. Number 21, g to the a equals 4. Well, I guess that's log base g of 4 is equal to a, is the rewrite of that. Number 23, new directions. Use the definition of logarithmic function to evaluate the function at the indicated value of x without using a calculator. So, trying to figure out what the log base 2 of 16 is here. In other words, what do you have to raise 2 to get 16? So your thought process might be similar to how we rewrote things up here. Until you get to the point where you're kind of comfortable with logarithms, you might want to write this down. That's the same as saying 2 to the I don't know what equals 16. If you rewrite it like that, that might help you see what's happening. Well, we'd have to raise 2 to the 4th power to get 16. So that's what we're looking for there. Number 25, what's the log base 16 of 1/4? Well, that's like saying 16 to the what power is equal to 1/4. Well, if you take the 1/2 power of 16, that's the same as square root. 1/2 power is the same as square rooting. And that would get me to 4, but that's upside down. So I must be having to raise it to the negative 1/2 power. The 1/2 power turns the 16 into a 4, and the negative flips it over. All right, where are we at? Let's skip to number 31. Number 31. We are solving, we're kind of just using some of the basic properties of logarithms. There's more properties coming in the next section. But if you have log base 7 of something equals log base 7 of something, those things have to be equal, so x is 9. Not too tricky there. Log base 4 of 4 squared. Well, log base 4 of 4 squared, that's like asking, what do you have to raise 4 to get 4 squared? What do you have to raise 4 to get 4 squared? 2, right? What do you have to raise 4 to get 4 squared? Or you could think about it as rewriting it like we did in the earlier problems. This logarithm is the same as saying 4 to the this equals this. Well, 4 to the x equals 4 to the 2, then x must be equal to 2. If logarithms are very confusing and mysterious to you, these are problems that you want to practice more than one time. Because once you understand what's happening, it ain't that hard. If I have log base 8 of something equals log base 8 of something, then they must just be equal, and 10 to the negative 1 is 1/10. That's 35. Number 37. More properties. Just want to simplify these expressions. Log base 4 of 4 to the 3x. Well, log base 4 of 4 to the something, that's like saying, what do I have to raise 4 to get 4 to the this? That's just equal to 3x. What do you have to raise 4 to get 4 to the 3x? You have to raise it to the 3x. Once you write this down, if you think about translating this into an exponential expression, like we did in the earlier problems, I think that might help. See why that must be true. Okay, what do I have to raise 2 to get 1/2? 2 to the I don't know what is equal to 1/2. I have to raise 2 to the negative 1 power. I just need to flip it over. Log base 2 of 1/2, that flips over the 1/2. That's this part of it. Log base 2 of 1/2 is negative 1. And 3 times negative 1 is negative 3. Number 41. Going to make graphs here. Important to know regarding graphs that exponential graphs and logarithmic graphs are inverses of each other. So if you know, like from the last section, what the graph of 3 to the x looks like, 3 to the negative 1 is 1/3, 3 to the 0 is 1, 3 to the 1 is 3, then your logarithmic, the points on the logarithm function, the inverse of that is log base 3 of x. These are inverses. So I'm going to go ahead and graph these. Negative 1, 1/3, 0, 1, 1, 3. Then to invert, we just flip the points, right? So for the g of x function, it's 1/3, comma, negative 1, 1, 0, and 3, 1. So 1/3 -1. That's the inverse of that point. That's the inverse of that point. That's the inverse of that point. The horizontal asymptote turns into a vertical asymptote for the logarithmic graph. And we get that. And we know that inverses are like reflections of each other in the line y equals x. You can see that nice symmetry there. Cool. I think we're going back to not graphing now. Let's see if that's true. Jump into 61. And we are doing more practice of writing, but this is just recognizing that when we have natural log, that the natural log is the same as log base e. That's what that means. And then we're rewriting these, so that means e to the 0 equals 1. So like earlier problems, we're just rewriting. 63, I have natural log of e equal to 1. That's because, remember that natural log means log base e. You can rewrite it like that if you want. E to the 1 equals 1. E to the 1 equals e. E to the 1 equals e. All right, I'm going to stop rewriting them like this. I'm going to try that, see if that works for you. So natural log of the square root of e equals 1/2. That's because e to the 1/2 equals the square root of e. Natural log of 9 is equal to 2.1 yada yada yada, because e to the 2.1 whatever is equal to 9. Keep going. We're going to change directions now and go from exponential to logarithm. So that's true because the natural log, that's log base e, of 20 and change is equal to 3. Right? Log base e, that's natural log, of 20 is equal to that. Exponent always goes on the other side when we're rewriting using logarithms. Number 71, e to the 1.3 is equal to 3.7-ish because the natural log of 3.7-ish is equal to 1.3. The cube root of e is equal to 1.39 blah 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 because e, what's the exponent that this is getting raised to? This is getting raised to the 1/3 power, right? E to the square root, the cube root of e is the same as e to the 1/3. The denominator is the root. So that means that the natural log of 1.39 is 1/3, because that's the exponent. Number 75, last one in this particular set, is, oh, did I skip something? No, sorry. The square root of e cubed, 4.48. The square root of e cubed, that's the same as e to the 3/2. There's a lot of exponent rule stuff going on here that we need to be confident with. That means the natural log of 4.48 is equal to, the exponent is 3/2. Moving on, 77 through 80, we're going to do the calculator. Let's practice pushing some buttons. Number 77, we want to find the natural log of the square root of 42. So let's see, natural log of the square root of 42 is 1.87. I think we should get in the habit, sorry, I have my calculator still set to give me 2. I think we want to write these 3 decimal places. Yes, that is what the book is asking. I agree. So 1.869. Number 78, want to find the natural log of 18.31. Natural log of 18.31, 2.907. Number 79, negative natural log of 1/2 is equal to 0.693. And number 80, we have the 3 times natural log of 0.75 as negative 0.863. And then the last 4 problems, I'm going to do 81 through 87, just using some properties like we did in earlier problems, but here with natural log. So remember that this means log base e of e squared. What do you have to raise e to get e squared? 2. Duh. Right? What do you have to raise e to get e squared? 2. 83. E to the natural log, since e and natural log are inverses of each other, they just undo each other, right? E to the natural log of 1.8 is 1.8. 85, e times the natural log of 1. Well, the natural log of 1 is 0, so e times 0 is 0. And last one, number 87, the natural log of e to the natural log e. The natural log of e, that's what you have to raise e to get e. That's 1. So this is equal to 1. Which is just equal to natural log e. And then what do you have to raise e to get e? That's still just 1. So that whole weird looking thing is just equal to 1.